cabinet over the way. I'm just going live. We're live on YouTube now. So I've got the coffee in my, it's lukewarm in my Christmas cup. So that's quite appropriate because it gets lukewarm very quickly in winter. Yes, it is. I wonder which way the jet streams swirl. But it is upside down. It really, it's whatever. Like if you're approaching Earth in a spacecraft, well, it depends what angle you're approaching Earth from, entirely. Exactly. Yeah. How indeed do they standardize those things? Well, I have to. Oh, so they actually did think that through. The writers thought that through. I appreciate that. That attention to detail is very important to those of us who are technically minded. Oh, so it's so what they've done. So what they've done is they've measured the noise of the universe in 3 dimensions, and they've taken a statistical. They've made a statistical inverse of that to add to the system to be the opposite. Noise cancelling. So it's all engineering principles. I think you just gave Dolby their next trademark, Dolby Universe. Maybe they already maybe they already have that. So Bill, you would tell. Oh, we've got Ian Cooper's joined in. He says good evening. I guess Ian, you must be further east than both of us. So thanks for joining us, Ian. You're on YouTube there. Would you like? I'm trying to get. Altium has this really great guy, Ben Kitzinger, who's. I just want to give Ben a shout out because he's kind of a behind the scenes unsung hero when it comes to, if you see all the most amazing video stuff, he's usually the guy, and people that work with him on his team. And also we have some real kick-ass graphic designers who help out with animation, and guys like Alex Benkei, Alex Cherkasov, genius, and there's a whole lot of other people there who work in that team that I don't know or haven't met. So, you know, I'm going to be in trouble for not saying everybody's name, but you guys rock. And yeah, but Ben, yeah, yeah, Ben Kitzinger and Philip Grove and Archana are on our team here, and they're just wonderful people to work with. So I'm hoping that they'll watch this and decide to help us out. That would be great. Anyway, but meanwhile, we'll rub our 2 sticks together and make a little fire, and we'll be happy campers. So, yeah. So Bill, you were asking me about rule scoping before. and this is an area, and Ian's chiming in, say he's just moved from Circuit Studio to Altium Designer 20. So Circuit Studio, one of the things I had to do with Circuit Studio was help R&D figure out how to simplify the rules scoping. And as part of that same project, we wanted to actually make the same ease of use decisions available to Altium Designer users. So we came up with this whole new system for setting up your design rules that had far simpler default rule scoping than just giving you a box that you had to type a query language expression in. Instead, what we did was we added these little drop downs that gave you the most commonly needed type of scoping for that specific type of rule. So for example, if you wanted a via rule that would determine your via diameters and hole sizes, you usually want to do that based on a geographical region on the board. Like under a BGA, you want smaller vias so that you can fan out more easily. Or you do it by net class. So if you have a power net, you want larger vias for better current handling and lower loss at DC. And so you would, oh, apparently, Bill, you're muted. Are you talking? Oh. I can hear you. I can hear you. I've got to make sure that the I've got NDI.
As long as you're hearing me, then I won't switch to a different mic.
I can hear you just fine. Yeah.
All
right.
Huh.
Yeah, I just unmuted you in XSplit and set it to audio output should be stream only.
Okay.
So hopefully that works and there's no echo.
Okay.
Okay, so
that's why we need a producer.
Yeah. Yeah.
Okay, go on though. You were saying.
Okay, so maybe rather than yak on about this, you brought this up because you had some questions about this week in your day-to-day design work. So maybe I should.
But since you asked about changing the rules under a BGA, I'll go ahead and ask, why is it okay to change the rules then if these rules exist for production purposes? Why do I get to bend or break the rules under a BGA? And I know the answer, so if you want me to chime in with an answer,
you may have a slightly modified answer, but
yeah, I was going to say an answer.
I would answer that by saying it's all about production yield and statistics.
Statistics, that's my answer. Statistics.
If you are making a board and you only need one of them to work, you can go to a PCB fab and say, I want 1 mil trace.
It's called wire wrap.
I want 1 mil trace in space. I'm going to use 0.4 millimeter pitch BGAs, so I need via in pad, and like you can spec the most crazy complex HDI board, and they'll charge you for it, and they'll make a whole panel of them. And they'll make panel after panel after panel.
And then test.
And they'll test them all, and the ones that pass the open short test, they'll send to you, and the rest they'll throw away and recycle the metal out of. They'll turn them to scrap.
Right.
So it's all about managing scrap quantities. And for the most cutting edge boards, like you wonder, why on earth is it so expensive? Because it's not taking the machinery any longer to make the board. Maybe there's some additional lamination cycles, so that does take longer. So there's that. But why is it exponentially more expensive to get an HDI board versus a simple run-of-the-mill 8-layer 5 mil track and space board?
Right.
Well, and the answer is they're throwing away half of them. You don't realize that until you've actually toured a fab and spoken with the people who work on the factory floor, and or you ask them to send you the complete panel with an X out, and you actually you collaborate with the fab to do panelization,
Right.
and you put a little fiducial mark on the side of each board around the edge of the panel. That was Freudian.
Panel. Fennel.
And they put an X with a Sharpie next to the ones that fail the test, and you'll see.
We did the same thing in chip wafers, only we don't use a Sharpie, but yeah, it's the same, but it's statistics. It's probing.
Probably blow a hole in it with a strong laser.
Oh,
Say,
yeah.
This one can't use, didn't pass.
So if we had a rule of thumb for people, it'd be make sure you get 100% test on your boards, even the cheap ones. I get 100% test. And if I'm looking at an online shop and they don't give me 100% test, I go somewhere else, quite honestly. It's because the idea is throw the board away while the board doesn't have any parts on it.
Yeah, indeed. So
and same with chips, throw the chip die away while it's still just a die, not a carrier around it.
So to come back to your question, what you can do is to say, to make your yields better, you have more trace width spacing, via sizes, you enlarge things wherever you can to make the board easier to make right first time for the greatest yield out of the panel possible. But if you have a tight BGA, you can just say, well, we'll just stick to the narrow features in just this region, and you put that more towards the center of your PCB, and that way when you are panelizing, the statistical likelihood of registration problems coming up
very good
in that area is reduced, because it's the further out towards the very edge of the actual manufacturing panel, which is usually 18 by 24 inches, so they're pretty big. The closer you get to the extreme edge of those panels, the more variation there is in X and Y axis during lamination, and so the more registration issues there are. So if you orient your boards and orient the component placement on the boards so that you have the fine pitch components, so that in the final production panel they're more likely to be towards the center, and all the others you use bigger features so they can be out near the edge and be a little off, but it'll still line up and work.
Right. That's a great answer.
And that's
a great answer.
That's the kind of thing you learn by either hard knocks and experience in the industry,
right?
Or you can do that, and
or go ask somebody and take the tour.
You actually go tour a fab and talk to them and do it. I recommend doing a fab tour for different fabs once a year for people who design boards, because it refreshes this kind of information. And if you really want to learn all the details about all of those sorts of things, you do something like a CID course, an IPC CID certification. Now, you don't really need a certification to be considered a great PCB designer. There's plenty of great PCB designers out there that don't have it. But it does consolidate and fill in gaps for these kinds of things. It's not knowing where to click in a software tool. It's got nothing to do with the CAD software, but it has the other side. It's
understanding chemistry, electroplating, mechanical registration, hydraulic presses, glue. It's so many things go into it. Paint, right? Silkscreen, UV, where you set it using ultraviolet light. It's very cool and expensive to have your own PCB fab.
Yeah. But the machines are so good that once you get a good assembly line set up, and you're all OSHA compliant and all that stuff, and you've got a good chemical process. There are fabs here in America, which here in San Diego, near where I live, there's a place called Hallmark, and almost 100% of the material that goes in there comes out as customer circuit boards. So even all the scrap gets recycled, all the chemicals get recycled, all within one factory. It's quite incredible. They
Well,
don't dump any toxic waste. Basically, the only thing that comes out of the only thing that comes out of the factory is PCBs and water. Because
okay.
here in America with EPA regulations now, they're so strict that that a lot of research has gone into how to reuse the chemicals in the process,
Especially heavy metals and stuff. Yeah.
And all of that stuff can be you can get it back again, but it just requires some very well thought out chemical and electrolytic processes.
I'm told there are two. I'm told there are two. I didn't mean to cut you off. That there are two businesses not allowed here in New Jersey, and one is chrome plating, and the other is PCB manufacture. That they've just outlawed them rather than try and regulate them.
Oh, really?
Yes, there's no PCB fab.
So I don't know much about chrome plating, but I guess that involves some pretty
same
nasty
chemicals. I think the same. I think early PCB fabs started at plating houses, and that's where the whole thing of acid traps and stuff. Well, yeah, I've never seen an acid trap that really trapped acid. I don't know that really happens today.
No, it
but
doesn't.
The fear of it comes from the days of etching, going to your local chrome plater to make a PC board, right?
I think the etching processes are so well controlled now.
Yeah.
To be able to go down to 1 mil trace in space, you can't, like acid traps are not going to be.
Well, let's talk about PC board material then real quick. What makes what is a good PC board? And what makes a good PC board? And you and I know when I say good, we automatically think of Nelcos and Rogers or something. But what's different about good material then?
Yeah, so like everything in this industry, the answer is it depends. A good PCB board material is one that it's like
doesn't deform.
It's the Venn diagram. A good material is the one that allows you to make what you've designed to within your specifications at the lowest cost.
Right.
And that may be, so for me, if I'm doing a custom audio analog board, a good material.
Phenolics good enough.
Phenolic is fine. And I will make prototype guitar pedals and things using 1 or 2 layer FR1. FR1 is flame retardant phenolic. And
that's like the old Cat1 cables or Cat3 cables in networking. It still works, but it's old.
And it has a higher dielectric constant. It's
slower.
It's very lossy at high speeds in RF. But I've done a little bit of RF prototyping with it, and if you're just doing a small circuit where you can tolerate a bit of loss, half of a dB of loss, that's fine. But or if I'm doing a very simple,
and we use two terms to describe loss usually, right? Everybody's heard of the dielectric constant, but then there's the other loss, the absorption loss.
The dissipation factor. Well, dielectric constant sets the capacitance of the material. It's the material's ability
I used
store.
the word wrong, but yeah.
The loss comes from two things. The dissipation factor, which is, or loss tangent is also called, and that's when the material is subjected to an electric field. It takes time for the
atoms to move and absorb
in the material.
It's drag.
And that literal movement of electrons and distortion of, it's almost like spring loading the atoms in the material, because you're biasing them with an electric field. They have to move and orient themselves in a particular way. And during that movement, there's loss because they're moving and they resist moving, and so they get hot. So you get lost.
I was going to say a little bit of heat then ultimately.
Yeah, and the faster you try to move them, the more lossy they get. And the other one is the copper resistivity. And copper has to be rough to key into the surface of the material.
Right.
Otherwise, you could just peel it off by hand and it doesn't stick. So they deliberately roughen the copper, and the copper foil is rough on one side, and that's pushed and laminated into the material under heat and pressure, so that the epoxy material keys into the copper, and that's how it sticks.
But that's bad too, having roughness, right?
Well, at high speed and
for
high
frequencies.
Yeah, because the skin
that's
effect,
where I live.
The skin effect makes all the current move through the very surface of that, and there's all these hills and valleys, and that causes loss.
Right. Yep. And
so,
and it can be very pronounced once you get above a couple gigahertz. The skin of the roughness of the copper. I was really surprised until I heard experts talk about these days how much gain they get by really smooth copper.
Yeah, and I thought this patent pending. I thought what I want to do is come
trademark,
up with
yes, registered.
Patent pending. This is my idea. I want a machine that has a selective polishing wheel that's very small, and so you get an inner lamination, and the reference layer. So the skin effect works like this: you have a copper layer, and your signal is on that copper layer. So you have a trace, and it may be a microstrip, and underneath the microstrip you have a ground plane. And the return path current goes in the ground plane directly under the microstrip at high frequencies. And the skin effect makes it so that almost all the current in both the signal and its return path are in the closest two surfaces, in a very thin depth, in the closest two surfaces between the microstrip and its return path on the ground plane. And so what I wanted to do was construct a board stack up where the key that gives the copper adhesion is there everywhere, except where you have a ground plane that's forming a return path. You have a selective polishing wheel that polishes it just where your high-speed
CNC polishing wheel.
It polishes the surface just where your trace is going to be over it, and then you laminate up on top of that, and then you laminate a core from the other layer. So the key that affixes the copper to the dielectric is on the opposite side to where the skin effect is going to be, and you do a selective polishing on that one. You have a pre-preg between them. You smoosh them together, and you have just polished only where you need to get the high speed, and everywhere else doesn't matter.
And you just said the word pre-preg.
You still have adhesion everywhere else, so the board won't delaminate.
Now, I came up through, when I was coming up through the ranks, we gridded our ground planes, and we called them ground planes instead of return planes and stuff. And one of the explanations that was given to me was eddy currents. And it turns out we used the word eddy current to describe anything we weren't sure of back then.
Right.
Some of the real answers are they were gridding it for adhesion purposes and selling it as eddy current problems. And nowadays, and you know, I'm also from the time when we put tinned copper under solder mask, and that's where you see those big old wrinkles in the solder mask that would peel off.
Yeah.
We used to do it, and we stopped doing it during the Commodore 128 because we were losing so much solder was leaving with the boards. So we did it for cost reduction.
Oh, that makes sense. I've seen a lot of boards from that era. I've had a lot of boards pass through my hands from that era that had that exact thing. And sometimes it was desirable. If it was a high power board, you'd get extra current. Sean, I think I've got Sean Upton is making a cool comment. He's like, it's not just copper, but also what's on it. Enig has nickel in it. Yeah, that's right. And we actually asked Lee Ritchie, who's a pretty well-respected expert in signal integrity. Oh, look, that's his book.
Lee Ritchie. Yes.
And he's like, he for anything over a few gigabits a second, he does not use Enig because of the nickel. Nickel has in Enig, there's enough nickel to cause issues, and it depends on the board fab whether they plate the nickel part really thin or thicker. But nickel has a permeability of up around 100 or 200. And so that gives your traces a lot of additional inductance. And
I didn't know that.
That can affect your high-speed signal integrity. So
Absolutely.
So I asked Lee about this. He says, yeah, I don't use ENIG. I use immersion silver. And immersion silver does not have that problem. And it's got a lot of other benefits. The only issue with silver is its shelf life, because the silver tarnishes very quickly.
Right,
yeah.
Right. And the organic ones and stuff all require that you QA, you can inspect it to see if it's been damaged, so you have to control the processes and whatnot. All the other, it's like every finish has positive points and negative points to it.
So Bill, I've got another question for you from Ian Cooper. He wanted to ask, do you tend to put long traces on one layer and short traces on another? Like,
no,
I'm and then changing layers quickly under the rivers.
I don't try to, but I end up doing that. And you end up with channels that you end up doing. So you might put all your long traces together is more likely than on a layer. But typically I use the backside layer for my long stuff or my stuff I can't fit on the top layer. So I start by doing the top layer first and then the long throws on the bottom. And then I swipe something out of the middle, and never, ever, ever use your return plane and break it up with signals. Not even one.
It's awfully
I'll let you
tempting.
explain why, but even one signal in the middle of that ground plane makes all the current go around it, and now they're sharing paths, and crosstalk goes up, and all kinds of stuff.
Oh, yeah. It gets nasty. So, Bill, you wanted to ask me for a tech tip.
Yes, I did.
And I'm just aware of the time. We're at 25 minutes in here, so
yeah, it goes quick, doesn't it? Let's do your thing. We're at that 20-minute call out that we did.
I'm just going to go to Skype, and for your Facebook viewers there, I'm going to start sharing my screen, and then
all right. And I'll tell you if it works. I don't see it yet.
You should see it.
I see it on the Skype,
and I'm going to. Yeah, and I've got you showing overlaid against my screen, the Skype call on YouTube. So people ought to be seeing that. So I've got my stroboscope still open from last week. How about that? I haven't moved all week. That's not really true. I've just been doing a lot of other things, but so you can see my board there. Now, your question when we were gearing up for today was about testing rule queries. And so if you look at design rules, go to design rules. Okay, got all these rules, and they're at the root of the tree, you see all these different types of rules all jumbled up there, and you can see this thing called scope. And that is controlling what objects the rule applies to. And so here we have the basic width rule. I only have one simple one because this is not a complex board. It's just a two-layer, simple design. And I have my minimum width, preferred width for routing. And so rules don't just say what's allowed and what's disallowed. Rules also are used to drive interactive design. And this is one area of difference between maybe Altium Designer and many other PCB tools out there. Rules used to be just a test to say, yeah, you've failed here and there, you've broken the rules. It would compare what you did against what was allowed. But that's painful because then you have to iteratively go back and fix things and rerun the rule checks. And so the way this tool's evolved is the rules not only test your design, they also drive it. So that when you're interactively routing, it will automatically pick a 10 mil trace because that's my preferred width. But I'm allowed to manually make it go down to 7 if I want. But there's this thing at the top that says where the object matches. And this is called a scope. And so for my width rule here, I'm just applying this to all rules. But let's say I wanted a special separate rule for my power nets like these ones. And I've already routed these manually at a wider trace width. But normally what would happen is I would say, let's go to here. I would normally have, and I won't hopefully get stuck in the weeds here. If I go to nets in the PCB panel, all the nets are grouped together. But let's say I have VCC, and let's set this to mask. So what that's going to do is highlight those objects, okay? And if I want, I can choose select and click it, and it'll select those objects. So it's just an alternative way of filtering and scoping. But let's say I want all my VCCs to be part of a group of nets, and that's called a class. So I'm going to select those, and what I want to do, actually I'll do it here. I'm going to right click in the net class list, and I'm going to say add class, and it's going to have, let's scope it to yes. Yeah. Yeah, I don't like loop removing on ground, for example, because I may want to place a lot of multiple vias and things, you know, stitching and so on. So I'm adding VCC and VCC18 to this class, right? And so now I want to create a new rule. I forgot to rename that class to power. Okay, so I've got this power class, and it contains all the objects in both of these nets. So now for design rules, I'm going to go design rules. I'm going to go to my width rule. I'm going to create a new rule. I'm going to scope it to a net class for power. And that's going to be still minimum 7s, because I want to be able to neck down to a narrow pad. But now my preferred is actually going to be 20 mil, and my maximum will be 100. Right? So now when I'm interactively routing, if I happen to be routing one of those power nets, my interactive route is going to pick 20 mils by default instead of 10 as before. So, but here's the thing, sometimes when you're scoping rules, so let me find a more complex one than that, okay? I'm just going to do an online DRC. Oh, yeah, I think we'll run out of time on that one. But let's go to VIA style. So let's say, let's see, I'm gonna find a better rule. You know, let's go. Okay, so that's here. That's silk to solder mask, right? So you can't have silk screen. And this is a good example too, because this is a good example because R&D added this rule type later on and did not update it with the current scoping feature that just looks like a nice friendly drop-down menu. So, but you'll notice that for all these different types of rules, you can choose a scope, and the list that appears in the scope should be sensible for that type of rule. So we did our research and found, well, these are all the things supported by that rule that make sense for that rule. But for this one, it's got the older style dialog where it's just a query expression with a default query. And so think, what's this query? You can still choose the default simple thing like pad class, say all pads. And let's say you're not sure how that's going to work. So we want to be able to test that. If you go to custom query, you might have some more complex query language expression in here, and you're not sure, is it actually going to affect any of these objects? So that's what this test queries button does. I'll move this down. If I click test queries, it gives us a little result. It says the actual expression, which is pad, is just going to return 193 pad objects, and that does not include vias because they're pads, they're different things. Objects applicable to the rule is also 193. The expression result, if there were an expression, so some rules have two different expressions. So the first object is a pad, but the second is anything else. So what that really should mean is anything that's a silkscreen object. So anything on the top or bottom overlay layers. So that's any kind of object. And there's an implicit filter query here that it happens to be on a silkscreen layer, which is not, and this is where things get a little confusing, because this could mean any object, no matter what layer it's on, but really this rule only will apply to silkscreen objects. So there's kind of an implied filter there. And so if I go to test queries, this is going to show me for the second query, it's just scoped as all, and there's actually 2002 objects that are scoped to all. And if I click on the 2002, it highlights all of them. But if I click objects actually applicable to this rule, it's only going to be 1952. And then for the first object query, it's all pads. So if I click on the 93, it highlights all the pads. And we can zoom and mask. Well, I know you'll say that, and I'll agree to disagree with you because the number is blue. It's blue, yeah. And when we did this, we didn't have the slate gray color scheme back then, and maybe it was more obvious. It was probably more obvious in the light gray user interface that had white backgrounds because the blue really stood out against white. And it looks like a hyperlink. Yeah, so yeah, maybe yeah, this is trying to go for a more modern UI look and feel. And in much older versions of Altium Designer, that would have been a T-edit box visual component that actually has a beveled border and is clearly a text box. And they look really old and out of date by modern standards. But you can't miss what they are. You know it's an edit box, and you can. So there's something to be said for those old user interfaces. But so this looks cool, but it's not immediately obvious. You can edit it. There's one more thing about testing the rule queries that's really important. So let's go back to my width rules again. So now I have a width rule for power. Let's say my minimum is going to be 10, just to be real clear. And let's say I have two rules now. So which one takes priority? Obviously, this first rule will filter out all the power items. But this rule here, well, it should be, but it isn't necessarily, because that's the order in which I created them. And this one says all. So doesn't this apply to everything? And if I go to test queries, it says the expression is every electrical object on the board, but the objects only applicable to the rule is somewhat less, right? And the reason, and I can't let me move that down again so we can see it more clearly. And the expression and rule priority says only these objects will be applied to this width rule. because of the power, see all the power objects have disappeared from that highlight. That's because the rule I added before is a higher priority rule and it's filtering out. And it tells me that here. The rules with a higher priority is this one. And that's those objects there. So this is showing me these objects are already filtered out by a prior rule. And that rule will apply to these objects. So they're not included in this rule. And so it shows me the negative. Or it shows me all the objects without those objects. So you can test your rule priority. And if something is not going how you want it to, it's probably because your priorities are, get your priorities straight. Come on, get your priorities straight. Down here, yep, it's always there on the main dialog for rules, and you can move them up or down. And it's just a matter of priority 1 means this rule is passed first, and then the objects move on. If they're not filtered out by that rule, they keep going down the list from 1 to many. So anyway, that took a long time. So I'm going to stop screen sharing there and go back to our chat. And I'm also going to stop my screen share. I'm also going to check the YouTube. Let's see if there's any other comments. Not really. So what else were we going to talk about before we wrap it up today, Bill?
Well, I got one last question for you. What is a silkscreen sliver and why are they bad?
Well, it is what you say, silkscreen sliver.
What makes a silkscreen sliver?
It's a really narrow piece of silkscreen that goes between objects that have silkscreen clearances.
So when you get two pads close to each other is when you start to worry about it.
And you said silkscreen and I said silkscreen, but we really mean solder mask.
Solder mask. Oh, yeah, duh. Thank you. Solder mask sliver. Yeah, silkscreen sliver. You know, you can't see the A from the G, you know, but the...
Yeah. So PCB, substrate, and copper are very smooth, flat surfaces, even though they have some key to adhere to each other. Solder mask is usually a special kind of paint that's spray painted on, and then it's etched away, much like copper is, chemically etched away after exposure to ultraviolet light through a pattern mask to determine where the silkscreen must remain. And where it does not remain, it's washed away. And it may be pressed down as a film. There's film screens, which are a very uniform thickness, and they're rolled on with a hot roller. But most PCB fabs now use a sprayer that spray paints a very uniform, but less uniform than a film.
Okay.
And then after the board's finished being made, you have these openings in the silkscreen, and if you have a very thin, like let's say 4 mils wide, 4 mils wide.
Less than 2 is where the limit usually is.
Yeah, if you have a very thin strip between two component pads of solder mask, then typically it's going to peel away. It's going to be very weak, and that causes a weakness in the overall solder mask. If that little strip breaks, it's an opportunity to catch on something, and that could end up peeling away huge sections.
Oh, so okay. So it's that lip it could get caught on or delaminate starting from that location. Then.
Yeah, there's that. So there's that practical side of it. The other
and I thought of it as you don't want that sliver to end up somewhere else on the board, then like underneath something, or on top of a pad or something.
Yeah, when the board goes through a reflow oven, that you think of it, you've got two big copper pads that are getting really hot, and they've got solder on them, and that solder is going to melt. And if you have this tiny little sliver between them, if it depends how close the pads are too, but the solder may you know, just having that hot solder right next to it may cause it to disintegrate or, you know, peel away. And then you
Explode
may,
off just due to whatever, yeah.
yeah, but either way, it's just, there's a certain width where they can't guarantee the accuracy or the stickiness for it to stick down. So it's kind of like a resolution thing as well.
We'll talk about solder dams next time, but that was a great explanation, and I never even thought of the delamination aspect of that, or the, you know, that spot where you can get under it.
Yeah, I think that's really the main concern board fabs have, is that you're giving it an opportunity to peel away.
Especially every board after board, you know, because you made it too thin to begin with. You know, it's not about one board usually, it's about, like you said, statistics.
Yeah, that's right.
So,
yeah.
All right. Wow, we talked about a lot of things there. It was PC board oriented, PC board Friday.
It really was. So what other stories have you got to close us out for this week, Bill?
Yeah, I was going to say, so what people don't see is you and me agree what we're going to talk about beforehand, and then we talk about something else completely when on the show, except for maybe one item or something. That's just the way it goes on a live thing. We end up talking about stuff that's interesting to us, you know, or relevant to what I'm working on at any one moment, for example. So yeah, I'm done for all my list of stuff. No more questions to stump you. How can you stump Ben with? Nope, we did that. So
you can stump me by cutting my legs off. There you go.
There you go. All right. Well, you want to wrap her up then?
Yeah.
Oh,
did you?
What time?
Well,
yeah, we have agreed on how long to do this for.
No. we can start to wrap up. Just one last thing. I just wanted to circle back to, you held up the Write the First Time book.
Yep.
We didn't really get to talk about that, so I think that could be book of the week right now. It's hard to get this in a printed copy, and I'm going to say it again publicly.
Well, I got this one from his website. That's the second volume, and that's still selling.
I had volume 2.
That's the first volume.
I had volume 1 and volume 2 printed on my desk.
This is by Lee Ritchie. It's called Write the First Time.
Yeah.
And it's Lee's talking about getting it right from the beginning, not doing it, experimenting, and having to correct it then.
Yeah, it's the Bible as far as...
Plus, Lee likes to ask, how do you know? You know, there's so many rules of thumb that I've heard over the years. Yeah. And I just love that attitude as, well, how do you know that? If even a simulation, don't forget that simulation's a tool. Real life may be different. Maybe the simulation helps you visualize it, but how do you know? And the answer is, you have really expensive equipment that I can't afford. That's how you know.
Right, but if
56 gig, 128 gig.
That's right, but if you follow Lee's principles of design, your board will actually be right anyway.
You'll get dang close.
So those books though, they used to sell as a pair, and it was like $200. And I had them.
Right, these are 100 each for me.
I had them, and somebody at Altium borrowed them off my desk and never returned them. So,
well, I hate to say it, I was using mine to get a little height when I was here earlier, and then I couldn't find it.
If you're out there and you used to be on Altium's tech support team and you have my books, I'll gladly accept them back. Thank you, and I won't take you to court for stealing. I'll just pretend
or send Bill Hurd after you.
I'll make it that you just had an extended borrow. But seriously, I don't really need them back. I've learned a lot from Lee Ritchie.
I've moved on. It's okay.
I have all the similar information from Johnson and Graham's books are great, and I've spent.
And I'm in the EMC stuff.
I've been able to spend face-to-face time with Lee, and he's spoken at Altium Live and taught people, and so all of that is really great material. But those books, highly recommended. And Bill, you said the first edition is now a free download from 007, right? So people can look for Write the First Time Volume 1. they'll be able to download the PDF. We highly recommend it.
For us
Excellent
that are
book.
into binders, which I am a binder person, I do not read big long things online or on my iPad.
I don't like that either. I get headaches. But I did that. So I told you last week I got my new.
There you go.
My new Rodel high pot tester, which stay tuned for that one. That's going to be fun. I found.
Here's one of mine on PCB stack up and stuff, and you might all the place mark holders in it or what's relevant.
Yeah, so I'm the same.
God, I could sit here and pull out binder after binder. That's how us old people stay organized, by the way. So if you start seeing your husband, father start doing binders, they're getting old.
Really?
Yeah, that was to your daughter.
Yeah. So I've got some comments from Ian and Sean about looking into rooms and how to use rooms for rule scoping and things. Sure. I'll put that in our notes for the next show. So,
yeah, Altium loves to talk about rooms because they are powerful. I'll give them that. But at the same time, if you're not using them,
usually just say, "What the heck is this? Delete it. Why does it?"
That's what I was going to say. Yeah, and what I do is I go into the ECO process when I'm first starting. If I'm not going to use rooms, and I tell it stop generating room additions for ECOs.
Yeah, and for simple designs, you don't really need them. So sure.
You don't. No.
But if you're laying out a board with even one VGA, it's worthwhile having at least one room.
That's exactly what I was going to say. Is that delineator is when I think of a BGA, I start thinking of a room. So
yeah.
All right.
All right. Well, thanks everyone for joining in, and it's been fun. Okay. Bill, any final
we
thoughts
talked a lot about high speed. I mean, we could talk more high speed PC board stuff later, but then I don't want to keep talking about high speed when there's a lot of stuff about DC and heat and stuff that I know that that I could learn from. So because it's been years since I've tried to put more than a couple amps on a PC board. But if you think about it these days, if a chip is 80 watts and it's running off of 1 volt, that's 80 amps,
yeah,
80 amps.
Yeah, you need a lot of copper on those digital boards to power the devices now. It's crazy.
A Cisco switch that has 40 channels of 1 gig's got to come from somewhere. There's an 80 amp chip in there somewhere is the way I figure it.
Yeah.
So just thinking about high speed is fun, but we got to think about our DC resistance and stuff too. And next time I'll tell you about how I found a bug in HSpice and it dealt with their DC resistance for coaxes. And I couldn't even do integrations and differentiation. And they're going, how'd you find that bug if you don't know math? And I'm like, I measured it. I did a Lee Ritchie. I took a spool of 400 foot of cable and it didn't match the simulation. So
I have this personal hypothesis about calculus that humans do it all the time without realizing it.
I catch a softball. That's an integration. Absolutely.
Yeah.
And that's why I tell people I can't do an integration, but I can catch a softball and throw a bowling ball.
There you go. Okay. Well, thanks everyone for joining us. Thank you on YouTube and Facebook.
Yep. Thank you.
And thanks, Bill. It's always a pleasure chatting with you. And
yeah, it's fun.
Look forward to what we talk about next time.
And we'll do that part now where you see all the feeds shut off one at a time until your feed is the last one to go.
Yeah,
so,
I'm just going to
goodbye, Facebook.
Goodbye, YouTube.
Goodbye, YouTube. Goodbye, Skype. Goodbye, Ben.